in this problem, you given a kind of complicated looking capacitor connected in series and the parallel combinations, and you have to find out the potential difference between the two capacitors. So it says you have to find what is the potential, the difference at this point and this point. So basically it is asking you what is the potential difference between these two capacitors, because these two are connected at the same terminals. So we have to find out the potential across this capacitor and the potential across this capacitor. So in order to solve this problem, we will break this problem into two independent components. The first independent system is this system. This is the one system, and the other system is this. We'll break into two parts. Our goal is to find out what is the potential across this capacitor, and then we'll find the potential across this capacitor. Now first we'll take a look at this one. I'm just calling this as a circuit 1. Circuit 1, and calling this as a circuit 2, just to make life a little easier. Now look at this circuit 1. These two capacitors are connected in parallel, and then it is connected in series. So what is the equivalent capacitance from this point to this point? First, these two are connected in series, in parallel. So the equivalent capacitance, let me write down, call this is C1, C2, and this is C3. C1 and C2 are in parallel. So the C12, if they are in parallel, you simply add them together. C1 plus C2, which is 9 plus 15. 9 plus 15, which is given by 24 microfarad. 24 microfarad. And then these two are together, C1 and C2 together is connected in series with C3. So the total capacitance C123 now, here I can write down that the C12 times C3, C12 plus C3, because these two are connected in series. C12, we already calculated this one, which is 24 times C3 is 16. 24 plus 16. If you do your math, the number you will get is 9.6 microfarad. 9.6 microfarad. So the equivalent capacitance between this point, at this point, and this point is 9.6. Again, between this point and this point, the net capacitance is 9.6 microfarad. My goal is to find out the potential across C3. So this one is simple to calculate. I'm calling this as a V3. The potential across capacitor 3 is given by, if you have C3 over C1, 2, this one is given by C1, 2, 3 divided by C3 times the applied potential V. Let me use the other pen. This is the applied potential V applied. This is C123 divided by C3 times, and this is V3. V3 is potential across these. Between these 2 points, the potential is V3. So what is that potential now? C123 is 9.6 and C3 is 16 and times the applied potential is 100 volt. So between this point and this point is 100 volt. So if you do the math, the number you will get is 60 volt. This one you will get is 60 volt. 60 volt. So I find the potential across this capacitor now. Now let me find out for the circuit 2 now. Circuit 2. Circuit 2 now. This is for circuit 1. Okay. Let me call this is a C4, C5, C6 and C7. Okay. C4, C5 and C6 all are in series. So C4, 5 and 6 I can write down by C4 plus C5 because they are in parallel. C6. So 4 plus 8 plus 12. This is 24 microfarad. And now all these capacitors together are in series with C7. So the way I can write down C7 4 5 6 is now C7 C4 5 6 divided by C7 plus C4 5 6. So C7 is 6 microfarad. This one is 24. 6 plus 24. You'll get 4.8 microfarad. 4.8 microfarad. So between these 2 points, between this point and between this point, the effective capacitance is 4.8 microfarad. Let me write down here. Now, what I'm going to find out the potential across the C4, C5 and C6 as they are in parallel, it should be the same potential. I'm simply call the V4. When I say V4, that means the potential across this capacitor. It doesn't matter where you measure, at this point, or this point. So the total capacitance, so the way you calculate it is total effective capacitance divided by this entire capacitance, which between these 2 points, C4, 5, 6 times 100. Okay. So this one is 4.8, and this the capacitance between these 2 points is C456, which is 24 times 100. If you solve this one, you will get the 20 volt. 20 volt. So across this capacitor, I get the 60 volt. Across this combination, I get the 60 volt. It doesn't matter where you measure at this point, or this point, you'll get the 20 volt. So the potential difference is 60 minus 20, and it is 40 volt. Okay. So although this sounds a very complicated problem, this is not a complicated problem. We just divided this problem into two circuits and we analyzed it separately and then calculated the potential across one capacitor and then calculated the potential across another capacitor and then took the difference that gives you the potential difference. Alright?